Okay, college algebra. One note is that these are the 4.1 notes that you'll be doing Monday, but I'm going to open a test this weekend over chapters 3, end of chapter 3 and beginning of chapter 5, and chapter 4 will not be on the test. So if you want to disregard this until you're done with the test, I'll send out more information on the test through a Canvas message. 4.1 is pretty easy. It's functions and inverses. So let's talk about, we know a function, every input has exactly one output, but we have a special kind of function called a one-to-one function where every output also has exactly one input. So if you remember scanning the x values and making sure they didn't repeat, though I could trick you if I gave the same y value, now the y values also can't repeat for different x values. So when you look at 1 as a collection of points, notice that none of the x values repeat, so it's a function. However, the y values, 2, 7, and 3, 7, the 7 has two different x values, so this is not one-to-one. And we'll write, instead of writing it out one-to-one, we'll write 1-1 because it's easier. So you can also do number 2. Number 3 is f of x equals negative 4x plus 12. To prove something, if you have a function is or is not one-to-one, what you're supposed to do is plug in a and plug in b and set them equal. So this is the y value of a and b because you're plugging them in. Now you need to get back to a equals b. So subtract 12, get negative 4a equals negative 4b, divide by negative 4, get a equals b. If you get exactly a equals b, then that means it is one-to-one. If you get anything else, like a plus or minus or anything like that, it's not one-to-one. Now what do I mean? Now your other option is if you think it's not one-to-one, all you need to do is find two x values that produce the same y value. For example, on number 4 for 25 minus x squared, you can show this isn't one-to-one using this strategy here, or you can say, when I plug in 1, this becomes 25 minus 1, which is 24. But when I plug in negative 1 squared is also positive 1, so it's still 25 minus 1, which is 24. So if you can produce 2 points that have the same y value with different x values, you can already show it's not one-to-one. Now, that's algebraically. Sometimes people will find it easier to show something is or isn't one-to-one graphically. So on page 2, you have f of x equals negative x plus 3 squared minus 2. If you remember your transformations for parabolas, this is a downward facing parabola that's moved left 3 and down 2. So it looks something like this. To show a graph is or isn't one-to-one, you remember the vertical line test for functions? That had to deal with x, because the x's couldn't repeat. For a one-to-one function, you've got the horizontal line test. So if you draw a horizontal line through the function, it can't hit more than one place. Now what you know here is it's going to hit 2 places, which means this is not one-to-one. It fails the horizontal line test. Generally speaking, notice that these two are both x squareds. All quadratics fail the horizontal line test. And in fact, any even power is going to fail the horizontal line test, because when you raise positive and negative numbers to even powers, they're both positive. F of x equals 3x minus 2. We can graph that. It's a line. It starts at negative 2, has a rise over run of up 3 over 1. Or down 3 into the left 1. If I do the horizontal line test on this thing, try to draw horizontal lines anywhere, it can't hit more than once, but it doesn't hit more than once. So this one is one-to-one because it passes the horizontal line test. So some people find it easier to do with graphs than with equations. So if you're more comfortable just creating a rough sketch and then using that, you can. Now at the bottom of page 2, there's a quick little example question about finding the domain and range of the inverse of square root of x plus 3. So first we need to find the domain and a point, range, and any point, we can choose any point, on the original. So what do we know about the domain of a square root? It's all of the x values that I can put into the square root, but we know that anything under the square root has to be greater than or equal to 0, which means x is greater than or equal to -3. Now we convert that to interval notation. That's from -3 to infinity. What about the range? What does a square root output? It outputs a positive, or really a non-negative number, anything from 0 to infinity. Now I can pick any point on this graph, pick any x value. I'm going to plug in 1, just because. You could plug in 0. If I plug in 1, I get 1 plus 3 is 4. What's the square root of 4? 2. Okay, so the main key about an inverse is it takes all x values and y values and it swaps them. Now, what does that mean for our domain, range, and point? When you swap x and y, it's easy to see what happens with the point. X was 1, y was 2. Now x is 2, y is 1. It just flips those two. It's less obvious to see what happens with the domain and range. The domain is all of the x values your function can take. Your range is all the y values a function can take. So if I'm swapping all the x's and y's, that'll switch. Let's think of the wording for domain. The domain is all the x values that your function can take. If I change every x in that sentence to a y, the domain is all of the y values your function can take, which means this range, which is originally with the y values, becomes the domain of the inverse. So your domain, or your range of your original, becomes the domain of the inverse. Similarly, the domain of your original becomes the range of the inverse. So you not only swap x and y for the point, you swap the domain and range for the inverse. So this would be, the domain of the inverse is from 0 to infinity. The range is -3 to infinity, including 0 and -3. And the point, instead of 1, 2, is now 2, 1. Page 3 is kind of redundant, so we'll skip it for now, because we've done it before. And then on the next video, we'll do pages 4 and 5. And 6 won't be something you encounter on your homework. It's something I like to do, but since we're not doing paper tests, it's gone.